always really nice to see some new faces and old faces to come back to this event and to see how this event has grown. This evening we try to do a little bit of a difference. We don't normally have a theme for our ferrochrome evening, but in light of the sponsors and what they chose to speak about, we decided, and also because it's topical, we decided that this evening's theme should be around and centered around energy. It's already old news that we estimate that the industry has been operating at about a 58% capacity utilization since the Eskom buybacks, and this has culminated in a higher benchmark price, short supply, and people left wondering where is the ferrochrome industry going. So to answer that question, we've got 3 speakers tonight, starting with Vince Agnello from Snowdon, who will discuss the impact of these buybacks on the ferrochrome industry. This will be followed by Conan Jones from General Electric, who will then discuss that things are not that dire and there are things we can do about electricity, until when he talks about cogeneration. And finally, we'll answer that question, where is energy going in this country? Is there energy in this country? Is there availability in this country? Ending off with Johan Pfister from Eskom. So without further ado, I'd like to please call upon Ian Falcon, one of our sponsors from Tenement Metals, to come and introduce the first speaker. Thank you.
Good evening, ladies and gentlemen. My name is Ian Falcon, and I have been asked by core consultants to introduce our speakers this evening. For those who don't know me, I've actually been involved in the commodities business for over 25 years and currently represent one of tonight's co-sponsors, that is Tenement Metals, which is a subsidiary of Monaco Resources Group based in Monaco. As Lara said, our first guest speaker, the one I'd like to introduce to begin with, is Vince Agnello. Now, I've got a pretty good resume here, which I'd just quickly like to read to you to give you some background to Vince. Vince has been with Snowdon for 6 years and is currently employed in the corporate division of Snowdon, where he's involved in market studies, technical reviews, audits and valuations of mineral resource projects. Recent projects include the listing of numerous junior mining companies, the valuation of several mineral properties, including platinum, coal, uranium and diamonds, and dimension stone companies, various due diligences in junior mining companies and advanced exploration projects, and in-depth reports on uranium, manganese, chromite, ferrochrome, vanadium and carbonates. Vince has also undertaken regional bulk infrastructure assessments in Namibia and South Africa for junior and major mining companies. Prior to joining Snowdon, Vince worked for 4 years at the Department of Minerals and Energy as a commodity specialist. His focus was industrial minerals, with particular reference to mineral markets, supply and demand, growth trends and statistical interpretation. Vince's paper this evening is entitled Eskom Buybacks and the Effect on the Ferrochrome Market. And I'm sure that you'll agree that it's very pertinent given the current global challenges and the competitive threats that our ferrochrome industry faces at the moment. Please join me in welcoming Vince.
Thank you for that, Ian. Yes, I've been asked to talk on the Eskom buyback and the ferrochrome industry. Just a little intro on Snowdon, who we are. We provide the following services: mining engineering, geosciences, geotech, technologies, corporate services, strategy optimization, training, mentoring, risk metallurgy, and so forth. A bit about the history of the company. We're in our 25th year. Started by Phil and Liv Snowdon, with head office in Perth and various other offices located around the world. If we look at our influence, over the past 25 years, we have completed 11,000 assignments, undertaken 4,600 projects for juniors and mid-caps, worked with over 90% of the world's largest mining companies, and provided data management and strategy optimization software as well. In the last 2 years, we've trained over 1,400 professionals from 382 mining companies. We've also done various other studies for ferrochrome and chromite companies. We would take the buyback. These are some of the headlines we see in the papers. Some of the bigger ones: Eskom pays smelters to shut down. Eskom buybacks boost ferrochrome price. And we've seen a few other headlines along those lines. If we look at the Eskom initiatives, over the last 5 years, we've had the Mandatory Energy Conservation Scheme, or ECS. Some have called it the mandatory load shedding. There's also the voluntary one, voluntary energy conservation schemes. There's cogeneration, demand participation, we have voluntary decrease of demand by the client, and sometimes some compensation with that. We've also the demand response aggregators, various incentive programs associated with that. So in a nutshell, you could say there have been voluntary ones, mandatory ones, and with compensation or not with compensation. That's kind of the gist at the moment. Eskom supplies about 95% of local power in 2011, and Eskom identified over the last few years a shortfall for the 2012-2000 period equivalent to 1,000 megawatts in 2012. And it wanted to secure 2,000 megawatts through buybacks. The understanding from what I understand, chatting with Johan at Eskom, is that this relates to Eskom wanting adequate capacity for when it is doing its maintenance. So that was the primary reason for the buybacks. Eskom forecasts a critical balance during the March to May period, which is now past. We are not the only country in the world that has brought this on. Recent buybacks include globally Japan, Burma, Australia, that have different types of buybacks, but along that thinking. In terms of Eskom initiatives, 133 of the top 250 customers, including 96 of key industrial customers, have signed voluntary ECS commitments to reduce their demand by 10% against agreed baselines. Eskom is hoping to make ECS mandatory as a last resort or safety net. At this point, the ECS has no penalties or incentives. Companies with signed-off baselines are currently saving on average about 6.4% against their commitments. Now, if we look at the buyback rate is determined by mutual agreement with customer, taking into account some of the following unique operational requirements: flexibility, fixed cost, Eskom's requirement that there are no job losses, and within Eskom's cost of electricity production, the buyback would have to be. So typically, your buyback would be less than the cost of running an open cycle gas turbine, or OCG as we call them. Eskom does not compensate companies for any foregone profits. In terms of buyback developments, Eskom has commenced with negotiating buying back electricity from large industrial customers from December 2011, and by March 2012 had already signed 800 megawatts of buybacks. Further to this, it costs Eskom about 38 cents per kilowatt hour from a standard power station, while the OCG turbines cost of production is typically around 40 per kilowatt hour, and in February 2012 these costs rose to £2.50 per kilowatt hour. The National Energy Regulator, NERSA, approved average increases of 16% in Eskom's tariffs from 1 April 2012. Originally it was planned for 25%, but those have been dropped down to 16%. More recent developments: Eskom's top 140 energy users consume about 40% of Vesa's electricity. These are reports in the industry. There could be great accuracy in that. Of which 40% of that 40% is used by smelters directly from the grid, which translates effectively to about 16% of South Africa's consumption. Eskom's weekly adequacy report shows demand deficit forecast for the week of 4 June and 18 June 2012 of between 2,400 megawatt and 2,100 megawatt. This is just an example of that. As you can see, just with little red robot signs for 4 June and 18 June. If we look at the ferrochrome industry and Eskom, ferrochrome analysts in the industry have estimated it accounts for about 6% of South Africa's power in 2010. SA is still considered the world's largest producer of ferrochrome, 37% of global output on a gross weight basis. 7 of the 8 ferrochrome producers have been approached by Eskom, and up to 45% of SA capacity was temporarily shut down through the buybacks. Snowden estimates the total buybacks are costing us from between 500 Rand a megawatt and 1,200 megawatt per contract. These are obviously not in the open, so we've had to do our own maths, and we'll never really know. But this is equivalent to a total Eskom cost of between ZAR $500 million to ZAR 1 billion Rand. This is just a quick snapshot of the industry, where you can just see the who's who, plant per company, ferrochrome furnaces, 2011 output, and then also a guesstimate of what we suspect the production forfeit, that production which we would have now lost through the buyback. So we've calculated at about 300, 320, somewhere around there. And then we've also just put out some of the latest status, just what has been recorded in terms of the buyback per operation. If we had to look at the ferrochrome price drivers, demand versus supply of ferrochrome as an input for stainless steel, the major use, we note that local ferrochrome Q2 production increased by 20%. So from Q1 to Q2, an increase of 20%. Although we've also got to remember that from Q4 to Q1, we actually had a decrease, somewhere of about 15% in terms of South African local production. Global demand, on the other hand, difficult to compare that for South Africa, but global demand, we note that from Q4 to Q1, there was an actual increase. So you could say then, for instance, that there was a much smaller increase in demand compared to some of the production that we've seen. Again, we've also got to remember that there is a historical connection. Traditionally, we also have a lot of ferrochrome production in Q1 through the industry. Then we also got to look at one of the biggest cycles is the stainless steel industry. And we've also noticed just that there have been some cutbacks at some of the majors, Power Steel, Lisco, and Tisco, and so on. And that inventories are still very high at a lot of things. So consumption globally, we noted from Q4 last year to Q1, an actual increase of 10% in terms of stainless steel consumption. So if you have all these factors in mind, it can be quite mind-boggling. But if we look at some of the following notes, in terms of, there's also lower ferrochrome stocks in Europe and America in terms of their stainless steel mills, and that's part of a cash conservation strategy many of them have been following. Further to that, we believe that China has adequate ferrochrome capacity at this point. So even although we're experiencing some cutbacks here, be it through the buybacks, etc., we still believe China has adequate ferrochrome capacity, and therefore we would expect an increase in chrome imports Q1 to Q2. But, so, what we're trying to say there is there have been increases from Q1 to Q2 in terms of imports, but nowhere near to the levels we had expected. You'll see on the next slide that those imports are actually lower than previous years. And then also at play, we're going to think of the potential bans that might be enforced in the next 6 months to a year, more soon in India than in South Africa, on unbeneficiated chrome. These would all have a knock-on effect on ferrochrome production in China, at least on the cost. If we look at ferrochrome consumption and supply, you can see that they tag along generally quite well. Just with a slight dip there in the 2009 cycle, mostly associated with the meltdown. Right. If we look at the Chinese chrome imports, we can see in the 2012 period, right at the end of March, we've had our increase, a Q1 to Q2 increase, but it's nowhere near to the increase that we saw in the 2011 period. So within that year, we can see there's just a bit of a lag there. So the traditional pattern following the increase in Q1, but not as strong as in the previous year. If we look at some of the ferrochrome more price drivers, there's a expectation that the ferrochrome price would have now increased. Now that we have the buyback, less ferrochrome from South Africa, we're a major player, there should be an increase. But, as noted before, Chinese smelter capacity is sufficient and cheap enough to take up any production shortfalls that have been noted in South Africa, and this happened last year to quite an extent as well. If we look at ferrochrome Q3, price negotiations in China, these will be completed in June. Though unfortunately in the Chinese market, most of it is on the spot market anyway. So what we noticed, for instance, in the Euro benchmarks, that Q2 2012, selling at US dollar 1.35 per pound, which is a 17% increase compared to the Q1, which was $1.15 per pound. Again, one's also going to apply various discounts on these prices, possibly 16 to 80%. There's talk in the industry at the moment. Further drivers as well include the Eskom annual price increase of 16% from 1 April 2012, and then also the Eskom winter power tariffs. Some refer to them as surcharges, but in the Eskom context they are considered tariffs from end May to end August, which are just slightly higher compared to any other period in the year. So historically, our local ferrochrome producers would build up their inventories in the first part of the year, and then because of the winter cost, typically your winter electricity cost is about 50% of total local ferrochrome production cost. So you would now minimize it in Q2, beginning Q3. If we look at the Chinese spot price for 68% basis, 60% chrome, DDP, using, in terms of renminbi, or yuan per ton, you get a value of, as of today, was 7,850 renminbi per ton. If you had to do all the maths, then you'd convert it from ton to pounds to from yuan to dollar and so on. You would at this point get about an equivalent of 1.93 per pound. So quite significantly lower than what you're getting in Japan and Europe and so on. Another sad reality of this is that about 25% of South Africa's production tons at the moment, are actually more expensive than this at the moment. So a large fraction of our industry, even at this point in time, isn't able to sell into that market. Here we can contrast just the high carbon ferrochrome contract prices for Europe and Japan over a longer period from March 2002 to March 2012. We can see they track each other generally, just with the Japanese just slightly higher, typically 8 cents more. So if we had to look at the ferrochrome to summarize, just all these different things playing in terms of price, demand, production, and so on. We notice that ferrochrome product prices are still quite buoyant. There's a premium for European and to an extent Japanese. However, these are all low volumes compared to the spot market prices for China and demand in China. So the EU bench prices are expected to increase moderately over Q3, anywhere from 0 to 4% quarter on quarter. We don't see anything greater than that, just with the current appetite of the market. Chinese spot prices are expected to remain at current levels. Quite an energetic market, very thrifty, and we don't see it going above $1 at any point soon. We also expect a moderate increase in chrome ore imports to China. We were expecting strong increases from South Africa, but that doesn't seem to have realized, partly because Chinese producers are looking specifically for very low-cost ferrochrome. So unfortunately, we do seem to be missing out specifically with LG6 and some of the high-quality ones. Kazakhstan's experienced similar as well. Then we have our low-cost base in China, which we feel is putting incredible pressure on South African ferrochrome producers. So cost-wise, we see it getting worse. And then also we expect lower ferrochrome production now through the SA winter, just the traditional Q3 period, where we see a lot more selling off of inventories than in Q2 and Q1. So just in terms of our last one, in terms of ferrochrome summaries, we expect that the buybacks may continue if the OCG is required to operate at higher levels. We think that the buybacks have been a very positive effect on the country and on a company level, particularly for high-cost ferrochrome producers, but unlikely to affect global supply and demand. As noted, China's self-sufficiency at this point in time, in terms of ferrochrome production, is such that the dependency on what South Africa does is becoming less and less. So to a certain degree, we're dictating less what's happening in the market just through our current cost bases.
What's the difference in the Eskom winter price, summer price? You know, is it 50%, 25, 100% higher?
Okay. I think if you look at our megaflex, you refer to megaflex. So I think the critical point is, and I'll come to my presentation, when you look in the peak periods of the day, which is early in the morning and late afternoon, that is about 6 times more than the normal standard tariff. Okay, so I mean that's the impact, and I'll touch on that on my presentation. I'll show you why. You know that there's a difference in the price signal and stuff like that. So, but in the peak periods compared, it's about 6 times higher in the high demand period, which is in June, July, and August, than it's in the, let's say, the summer, which is the remaining 9 months.
Thank you, Vince. We're going to have a little bit of a program change here. We had scheduled, or Nara had scheduled to have Colin Jones from General Electric speak now, but the last I heard, the gentleman was stuck in traffic or had a problem with his motor vehicle. So we're going to move Johan Sister into our second speaker role. I think most of you know Johan, but if you bear with me, let me give you a little bit of background to Johan. Johan is currently employed at Eskom as Senior Manager, Key Accounts in the Group Customer Service Division. He's responsible for developing and enhancing relationships with key industrial customers in the Limpopo and Mpumalanga province in South Africa, in order to ensure that their needs and Eskom's interests are optimally balanced. Johan began his career in 1974 as an apprentice and qualified as a technician in the Protection and Metering Division in Bellville. He worked in various departments in Eskom as District Engineer, District Manager and Customer Service Manager. Johan was part of the Eskom delegation that went to Brazil and the United Kingdom, tasked with investigating new customer service processes. For a short period, he's also worked at the Copal utility in South America and in the Republic of Congo, Brazil. Apart from National Higher Technician Certificate, Johan also holds an MBA, which he obtained through Henley University. Johan will be speaking to us on future available capacity, and without further ado, I'd like to call upon Johan to come and present his paper. Thank you.
Okay, good evening and thank you for the opportunity. I was thinking, should I go and fetch my laptop and get the tariffs out and bore you with that? And but anyhow, I mean, next time we can talk about tariffs. And I think what's appropriate is there's 2 national initiatives going. It's basically looking at what type of power or generation mix we require in South Africa, and then we refer to the yt2, the multi-year price determination for the next 3 years, which should, I think, unfold a lot towards the end of this year, the beginning of next year. Because you need to know what your power mix from a generation point to determine actually what your tariff structure is required going forward. So you need to look at both of that, and quite frankly there's a lot of initiatives going on from that point of view. So that's on the tariff side. The second aspect is, I believe tonight I'll try and give you the best what we know of the system, what we know from the customers. And some of you are customers directly from Eskom, or others in the municipality environment as such. We look, in our environment, we look after all the municipalities, and the top 140, like Vince referred to, are the key industrial, as we refer, key industrial customers in South Africa. So our division looks after about 90% of Eskom's revenue. So in my portfolio, ferrochrome is big, platinum big, and so we look at about 14, 15 different commodities in the Limpopo, Mpumalanga area. Plus, so it's quite a mix. But what I want to urge you, when you leave tonight, you drive through Gauteng, you see lights on. And you'll see lights on. Our initiative here is to keep the lights on, but not unnecessary. So please use your finger, switch lights off, and encourage that going forward. Okay, so that's... I will be covering some of the current situation, outlook of the future, addressing the challenge, and partnering to keep the lights on. Eskom at a glance, we need to balance between socio-economic aspects, commercial aspects, environmental aspects, and to provide sustainable electricity solutions to grow the economy and improve the quality of life of the people in South Africa. And Eskom plays a central role to support the new growth plan of the government. If you look at the Eskom infrastructure, it's most of our power stations is in this environment, and you'll see that we've got a nuclear power station in Cape Town. We refer to open cycle gas turbines. It's at Atlantis, Port Elizabeth. It's future ones, but the other big one is at Gorikwa, close to Mossel Bay, and then we've got two smaller plants at Port Rex at East London and stuff. But you see 765 lines in the development going down to Cape Town. We're busy with two power stations, which I'll touch on later, but I have to show you on this graph. The one is in Lepelade, the other one in Witbank. And just an interesting point of view, from Lepelade down to, let's say, around to Brits environment is about 260 kilometers. We have to go with our power lines over 69 proclaimed game farms. And I'll touch on that specifically with growth in South Africa going forward. So that's a mix. You can see what went out from a generation point of view. And if I show you the next slide, you'll see from, and Vince also referred to that, total Eskom sales, but I think what's important, the ferro-alloys of South Africa is about 8.1% of the total Eskom sales. And from a key industrial point, so this is plus minus top 140 customers, that represents about 19% of our basically revenue mix from that environment. And we also refer to on the buyback, roughly about 871 megawatts was secured from the alloy environment. Current reality is South Africa overinvested in generation capacity in the 70s and the 80s, and Eskom motivated to utilize excess capacity. So some people said to us the other day, you had red hanger sales and stuff like that in those years to encourage the use of electricity. Now you want to take electricity back or buy back, and say, how do you balance the two? In recent years, South Africa's electricity supply system has come under severe pressure due to limited new generation capacity. And the concern we have is that in next year, no new generation plant will be connected to the grid, which is a major challenge for us, because you will have growth, you will have intensity of electricity, you will have demand-side management initiatives, but at the end of the day, you want to see production going up, and you want to see generation or energy usage to go down, so the efficiency must improve. But that comes at a cost, and some of you are very involved in a lot of these initiatives in South Africa. The recent economic downturn has provided temporary relief, however, demand is on the increase. If you compare the current situation, we can go back to 2007, and it's almost exactly there. And if you add all the buybacks and DSM and stuff like that, we're actually exceeding what we produced or generated or grid required in 2007. Further, this is our concern, which I would like to point out. The dotted line is our summer profile, and the blue line is our winter profile. So if you look at these two arrows, you'll see that this jumps between 2,000 and 4,000 megawatts in about a half an hour. Now what does it equate to? It equates almost to a Matimba power station. So this is one of our base power stations, and that's what we are challenged. We need this, otherwise this area, because that will allow us to basically pump water and for hydro in case we need it. So all our initiatives are going to manage this, and Vince referred to the open cycle gas turbines. Some nights we run all our open cycle gas turbines, we use our water, everything. So that's a real challenge we need to manage in our organization, because when we get home, everybody switch on. So what we are urging, please switch off, just use the necessary equipment. So our key industrial customers are helping us a lot here by moving their production. It comes at a cost for them, it comes at a cost for Eskom in this situation, or such a incident, for example. Expected system statements. On Friday, our Chief Executive will go nationally on a quarterly system update, and his forecast will look totally different because he will be doing it on a daily basis. I'm doing it on a weekly basis. So what's important here is every day we give 2 reports through to our key industrial customers. What we can generate and what the system demand will be, to see what's a balance and what reserves we can use or fall back onto. So the week might be yellow, and you'll see the green, yellow and orange, but in that week you will have red days. What I mean by red days, it's like you going to the airport and you're booked, and when you want to get on the plane, they say it's overbooked. And that's a situation we are dealing with. So that's a major concern. So certain days we really have a major challenge. So we've got our merit audit, what we can use from a generation point, what customers can assist us to drop demand, and what we can buy back on various aspects of various programs. The important part of this is that this picture will be with us, I'm of the opinion, to 2014, first quarter of 2014. So 2013, we're going to have a serious constraint period. We look at this every day, from our point of view, and we look at the mix. And in this period, with the constraints, there is no reserve margin certain times of the day, not the whole day, certain times. We also have to do maintenance. And we must also recall that we've got an old fleet. We don't have new power stations. We're busy building Medupi and Kusili, one of our pump storage scheme, which will only start coming online in 2014. Okay. This is our major concern. You've seen this. The thing that changed is the years here, but the terawatt shortage. So what we are predicting in 2012, there will be a 9 terawatt hour shortage, which is equivalent to about 1,000 megawatt base load. And 2013, 3 terawatt, and 2014, 2 terawatt. So a lot of initiatives are going on from a generation point of view, but as I'm standing here, this is the best information we've got to see how our supply and our demand and the usage, how that's in sync or out of sync. So this is a reality where we have to balance from Eskom to keep the lights on. If you look further, I refer to old fleet. So if you look at all our generation plants, I started my career in Kuba, and that's over 30 years old. So, and we think it's a relative new generation plant, nuclear. So if you look at the blue line, you see that's the area maintenance we require. This will be the first year, I can say, for as long as I know in my career with Eskom, that we will do major maintenance during the winter period, June, July, and August. Because if we don't do it, we can have a problem going later in the year, in the beginning of next year. So we have to take plant out, a big unit, and some of our fleet You take, like in Kuberg, you take about 800 megawatts. The system requires also about 100, so roughly 900 to 1,000 megawatts when you take one Kuberg unit out. And you have to take a Kuberg unit out every 18 months to refuel, do maintenance and stuff. So if you take a Letabo plant or a timber plant, you have to take those units out. The big challenge we have, if you take it out for big maintenance programs, because legislation says to you, every so many hours you have to do this inspection and you have to do this maintenance. Sometimes when you open a turbine, then you really come out. This turbine was planned to be out for a week, 2, 3 weeks. So you have to reschedule. That's why I showed you that color insert, the colors of are we in a green day, yellow or red day, changes from week to week from that point of view. So the buyback, in essence, was to create space that we could do maintenance. So that's why we started in December, right through till tomorrow. Okay? And it is actually tomorrow. The other hand is, if you look at the shortage, the supply, the challenges for customers, we also need growth in South Africa. So the projects we are dealing with now currently in the mining environment is roughly, this is just large customers. This is projects above 15 MVA, up to 200-300 MVA plant. 50 projects, so you can see in coal platinum, you would expect that in the coal, that should be about 33. But it's roughly, that's what we are dealing with currently. So 2,000, just over 2,000 MVA in the mining side, industrial projects, ferrochrome, and some of you might challenge us that, and now we're back. This is actual projects we're dealing from, let's say from a feasibility to the execution phase. So we're looking at 2,900. So if you add those two, and not even talking about Transnet, we're talking over 4,000, between 4,000 and 5,000 of megawatts you're going to add to the system. Currently, there's certain legislation, certain requirements and stuff. About 5 years ago, we could develop this in 36 months of project. Currently, it's 63 months. So that from the day you walk in with Eskom and say, I want to develop this plant in whichever area in South Africa, I can assure you, we will only be able to commission that plant in 63 months. 18 to 20 months, or 18 to 2 months to 24 months is environmental aspects and in designs and stuff like that. This is the biggest frustration for Eskom and the bigger frustration for you as a customer. Because a lot of people are believing that our engineers are not doing enough and stuff like that. But I can assure you that's the dynamics we have to deal with currently. I've not even added the municipalities. Because when I add the municipalities, because they just have to give you as a customer, supply to home, provide electricity to new shopping malls and stuff. If you add that picture, it even gives you another view, which is also a major concern. Then we look at implications if the gap is not closed. The electricity supply system will be under severe pressure, posing a risk on security of supply. Using open cycle gas turbines to mitigate the risk is expensive, ultimately increasing the price of electricity. And Vince showed us what is in public domain, in the cents per kilowatt, and the cost. Imagine what the diesel is going into those plants and what that's doing to that environment to ensure there's enough diesel. Because all of us do have generators. Now in the complex I live, I don't have a generator because that would give a total wrong signal to my neighbors. But I can show you what. Okay. But that's not the problem from an Eskom. The city where I live is a major problem. Okay. It will not be possible to connect large expansions until we have the capacity negatively affecting current economic development. We are pursuing those projects. And there is certain limitation of what you can do and how you can do. And we will assist you as far as possible. That we can give you the only major concern, if you're not part of a big group, it becomes more challenging starting up a mine or a plant and stuff, but we will definitely assist as far as possible. South Africa's sustainability, reputation and competitiveness will be negatively affected if we don't have and ensure that we basically stimulate growth from that point of view. I know it's a risk on a customer and investment point of view, but I can assure you, not all countries you can go and at least you look at the quality of supply in South Africa. It's still ranked in the highest in the world. About 2 weeks ago, some Indian businessmen were here and they focused on quality of supply because that's why they have to relocate and stuff like that. And there's no ill feeling about any country. And I put the quality of supply graphs up and they said they don't believe it. The biggest drive from our chief executive to ensure that the quality of supply is of the best in the world. And I tell you, all our focus are going into refurbishing and to ensure that supply to plants and mines and stuff is of the highest standard in the world. Pressure to reduce supply to neighbouring countries could have negative political implications, and I need to say to you also that we are importing a lot from our neighbouring countries currently. Further reputational damage, the government and the electricity industry lost opportunity to unlock economic efficiency through more efficient use of electricity. And I refer to, and I can say to you that a lot of our operations, you look at the production and you look at the energy intensity, that's come down. So the production went up, electricity intensity came down. So cogen plant, a lot of other aspects which assisted and will assist going forward. Proposed solution to close the gap, sustainable additional energy required, capacity expansion, ESCOM build, IPPs, and network expansion. In the short term, demand side solutions are more readily available and less expensive. And I'll touch on that. Current plant capacity, so if you look at 11-12, and you'll see 12-13, about 1,194 MVA will be connected to the system, and the following year, 2013-2014, another 2,000 MVA will be connected. So current situation is this year, next year, and the following first quarter, we're going to have major challenges to balance the supply and demand in South Africa, and we have to work together from a customer point with ESCOM, from the ESCOM point of view. And so this is just a few photos of Medupi, Kusile, and some of our networks, and Ngula power station. Independent power producers, big frustration from your side, from a customer point of view, new investments in South Africa. But what have we done from an ESCOM point of view? We've established a grid access unit to assist you as a customer or developer in that environment. That's starting to basically take over a lot of these contracts and take it further. So we've got expert people, so if you want to get involved in cogen or IPPs, there's people in ESCOM you can talk to. But you must realize that there's a lot of legislation we also have to comply, as you as a customer have to comply or invest. So ESCOM has signed up megawatts through the medium-term power purchase program with Sasol, SAPI, IPSA, and Tangent. ESCOM supporting 2 municipalities to operate their generation plant. So there's hardly any generation plant in municipal areas in South Africa which we've not engaged with, which we are not having contracts or pursuing contracts going forward to make sure that we get the supply and demand situation under control. 2011-2012, ESCOM purchased about 4,000 gigawatts from local IPPs and cogeneration. ESCOM also purchased about 1,833 gigawatts from local IPPs and cogeneration, an average cost of 76 cents a kilowatt hour for non-ESCOM generation and 53 cents for ESCOM indicates real price of generating of electricity. And government's integrated resource plan creates framework for introducing further IPPs, renewable energy, IPP program and progressing well. So that's what I refer to. So you need to have a plan to say this generation plant you're going to connect to the system or you're going to other support in South Africa to really determine what tariff you require. Because currently our capital bill is enormous. It's over 500 billion rand and somehow we have to fund that. And some say over 5 years, 10 or 30 years. But the essence is that we as consumers have to fund that bill going forward. South Africa focus on energy efficiency to contribute to the solution. South Africa has moved from a period of abundant, cheap electricity to a situation of looming shortages of supply and rising electricity prices. Demand management options, specifically energy efficient, is the least cost, best environmental friendly short-term solution to address a number of challenges facing South Africa. Creation of space for generation, maintenance and new connections, more time available for new generation decisions, positive impact to contain electricity price increases, and positive impact on the environment. A collaborative approach to meet energy efficiency targets is essential. ECS, we've referred to that. Once referred to the stats, baselines in South Africa, and how many customers are participating on that. And this is the last step that we would like to implement. And it will not be up to Eskom to say implement it, it will be a government decision. And that's my understanding, it's my personal understanding, so I will not dwell on that even further. So please partner with us, embrace energy saving as a national culture, joining the global journey towards a sustainable future. 49M campaign aims to create a culture of energy efficiency in South Africa. Remember the 3 P's, power, save your pocket, and save your planet. If you're not using it, switch it off. Thank you.
For that interesting and informative presentation. I'm sure my wife is going to be somewhat distressed to know that she's going to have to wait till 2016 before she can get the electric blanket out of the cupboard. I understand.
So you can use it, just use it after 8 in the evening.
I understand our other speaker is here, Conan. Conan Jones, if I can just quickly introduce him to you. He joined General Electric in 2011. His responsibility is to drive all sales across sub-Saharan Africa. He's supported by commercial operations in Austria. Conan came into General Electric with 10 years experience in various industries from international product management, marketing and business development, and prior to that he was involved in the instrumentation, calibration and certification field for South Africa's National Measurement Standards Authority for South Africa. He is qualified as an electrical engineer at the University of Witwatersrand and has successfully completed an MDP through UNISA. Colin's going to be talking about furnace waste gas to energy conversion and cogeneration, and I'm sure you'll join me in welcoming him to the table.
Hey, good evening, esteemed ladies and gentlemen. Right, parts of this presentation are thanks to very knowledgeable colleagues from, or friends and customers from AAP Carbon, joint sponsors of this evening. And the PC problems that I was having was that I wanted to really drastically reduce this slide presentation because it is a humongous amount of slides, typical large corporation fashion. So if I go through them rapidly, you can consider it a form of subliminal advertising. Okay, so there are going to be some slides that I'm just going to zip through because they are more corporate. And if we go back to the founder of GE, Mr. Thomas Edison, you could call him one of the first large consumers of electricity with his nasty filament light bulb. But this quote of his also puts us in the position where we stand today with the technology I'm about to present you. That we find out what the world needs and then we proceed to invent it. And the concept of converting furnace waste off gas to electricity in the form of cogeneration, which both Johannes kindly opened up my presentation for me on that, is exactly this type of thinking. Right, so GE possesses a range of gas reciprocating engines suitable for this type of application, and currently we believe we are the front runners in converting furnace off gas to electricity in the form of cogeneration. So our head of gas engines, Rafael Santana, says that we strive to create innovative custom tailored solutions. And I think there are some well-known incidents of that in South Africa, or references of that. So we generate electricity from gas, various gas forms, for cogeneration, for IPP, for captive power inside industries. We generate them from all sorts of different gas streams, either from bio, which is nice and green. I always like to present our solutions as being 50% reliant on fossil sources, which we use very efficiently, and the other 50% are very green. So we have what we call our application landscape, where these are all the different types of gases that we use and the different types of industries that we support to either utilize their waste or to utilize their energy more effectively, more efficiently. And the one we want to focus on is this one, special gases. And we've put a point up there: industrial waste gases, power produced from steel, ferroalloy and chemical industrial waste gases. It was a very big fight to get ferroalloys into this statement. I see some thumbs up at the back there. And this is because of traditionally where this development came from. It was primarily developed for the steel industry, using the blast furnace gas, the LD converter gases, and this was done very successfully in Spain, at Arceralia, at Profusa, where our engines are up and running. And it took some very clever Boermakkerplan thinking to realize that this process could be adapted to our ferroalloys industries as well, where effectively you are trying to strap a thoroughbred racehorse to a donkey and get them to run at the same speed. You might wonder what I'm talking about. You have got runaway hydrogen, which is extremely volatile and explosive, and you've got an abundance of carbon monoxide, which burns, but very slowly. And you're trying to get these two mixed correctly in a cylinder and ignite it to create power. And thanks to a lot of research done, some would call it guinea pigging at some of our large customers, we've been able to achieve that. So special gases could come from pyrolysis of wood, or in this case, a very large steel industry. Some of the next slides were actually the beginning points of this line of thinking. Coal mine gas, just as an aside, is something else that we can work with as a product that goes into coke ovens. The types of engines we use, I'm just going to breeze through compression and heat recovery and our services. And here we go. Now the presentation starts. So thank you for bearing with me on that. So furnace waste gas to energy conversion and cogeneration. These are the different types of gases that we burn: natural gas, biogas, synthetic gases. And unfortunately, right at the bottom, they put coke gas, and on this slide it doesn't even show furnace off gas. This is the spectrum of the calorific values of the gas that we can burn. And you can see that coke gas sits somewhere in the middle, which means it's quite suitable for what we want to do. But like we said, we've got to try and get these two beasts to run together. So in an integrated steel plant, these are the different gases we can pull off. Coke oven gas, from the primary production of the reductant that goes into the furnaces. Blast furnace gas, blast oven gas, and you can see that we do have some large facilities burning this gas. Okay, and these are the typical compositions of the gases. So coke gas, up to 50 to 70% by volume of hydrogen, but you do have to clean that gas a heck of a lot before you can actually do something with it. Blast furnace gas and converter gas. So these are the case studies and references, and I think some of the colleagues in this room actually visited these sites to determine that it could be done in South Africa. Okay, so if we put it into a South African context, what have we actually done here in South Africa? And this is the next few slides are courtesy of Jacques Malan at the back there. Sorry, Jacques, I borrowed them without asking, but you had presented them publicly. So. Right, so this is what we motivated to my marketing colleagues to try and veer their minds away from focusing only on steel gas, and we needed them to think about furnace off gases in general, because that list actually doesn't contain what would traditionally be called steel. And yet our majority of solutions in South Africa thus far are in that area. It's a very loose definition, so please, the purists among us, don't beat Jacques up for putting titanium oxide underneath ferroalloys. But essentially, this ties in very nicely with what the first two speakers spoke about, especially in terms of the consumption in South Africa. And if you add the auxiliaries and the actual running consumption of the plants, this means this is where we've got some space to play. And what we're proposing is that on the closed furnaces, to start with, in this industry, we could theoretically, and so far proven by reference, give back 10% of that generating capacity. And as the legislated and mandated moves go ahead to close current open furnaces, it converts this market quite significantly. Currently, the only solution to open furnaces are heat recovery solutions, whereas closed furnaces, we've got the gas engine solution. So the name is up in lights. I think everyone is quite familiar with this, a very successful implementation, not without its teething problems. Currently part of the Eskom buyback. We're actually really looking forward to the system going live again and generating up to 17 megawatts back onto the grid. So these are part of the photos of the actual line, the blower fans. And so here we have the actual furnaces and the ducting that runs the gas about 450 meters. It's about a meter diameter ducting that runs it to the gas engines through some filters and cleaning. And the green beast, I was supposed to wear a green tie tonight, but I just opted for blue because gas burns blue, in my book at least. This is IFM's situation with 10 of our gas engines, each generating 1.7 megawatts. And we've spent a lot of time doing research here. Some say we've spent too much time researching it at the expense of others, but we believe that the end benefit will justify that. We actually believe that we might be able to get 1.9 megawatts out of each engine. Another uptaker in South Africa, also we want to thank these first early adopters for adopting this type of technology before it's really proven worldwide, is South African calcium carbide. They've just taken delivery of 4 new engines. They're in commissioning at the moment. They will also each generate about 1.7 megawatts off gas. So what do we do in terms of innovation and continuous improvement? Now, these are the last bank of slides. These came to us on the 3rd of May, and those of you in the industry who've looked at this type of solution might be quite encouraged by what we've done here and the numbers that we put to it and the clarity that it now brings to waste furnace gas. Essentially, we have had this curve for about 3 years. It determines the configuration that goes into the engine, the piston size and how the timing of the firing and so on. And it basically shows what types of gas compositions we can burn. So on the far left-hand side, if you have a gas composition of a large volume of CO and a small amount, up to about 5% of hydrogen, we can guarantee power output of about 1.7 megawatts per engine. And moving along, the next band, the blue band, band 2, was specifically developed for the IFM project. There was a gap in the development at that stage, and that was specifically developed, so it was quite an innovative step. And there we are now guaranteeing 1.7 megawatts in that range. But some have said that these curves are too defined. What happens outside the curve? What happens if your processed gas coming off your furnaces drifts? Because you're at the mercy of a smelting industry that's primary output is metal. They really don't care what reductant they put in, because as long as they get metal out the other side, they're quite happy. Whereas if you are taking the gas into consideration and the reductant going in there, whether it's coke, anthracite, coking coal, or a mix thereof, or different grades thereof, you get different qualities of gas coming out. So we have innovated further and defined these curves. So here we're talking about the guarantees that we can output, 1.7 megawatts, 1.7 if it's within those bands, 1.7, and we have a potential best power output here of 1.9, close to 2 megawatts. And on type 4, if I just go back to those gases, you can see it's these two gases which are more 50-50, well, a different proportional split of hydrogen and carbon monoxide. So we've now defined what happens outside of these defined bands, and a lot of people got very happy when they saw this curve, to show that we can actually keep these two thoroughbreds, well, a thoroughbred donkey and a thoroughbred Arabian, running together just with some reduced power output. And I think the maximum reduction is down to 1.2 megawatts. I think if we keep within at least the coloured area. These are then defined for the three primary areas. So as you can see, we are continuously developing this solution. We are currently in a position where there are 17 engines in country. SACC is commissioning their 4. There are 3 that have just recently changed hands that will also be going into a smelting industry. And Namakwa Sands has placed an order for 8. They will be processing their ilmenite gases in the production of their titanium oxide, which puts us within this year with 25 engines, each generating about 1.7 megawatts. That actually puts us ahead of the entire coke oven gas, blast furnace gas, and other types of furnace off gases in Spain and Europe. And there are several projects underway, I'm sure a lot of you know about them, that will actually add another 48 engines to this existing fleet of 25. So we actually see this type of innovation having happened in South Africa, and the pull-through of these types of engines to satisfy the open invitation of Eskom to step in the direction of cogeneration will actually put South Africa as a world leader with the largest fleet by a factor of 4 in the world. And we believe with our combined experience and expertise in this room and in the industry, that in this field alone, we will actually become a centre of competence worldwide for furnace off gas to power generation. Thank you.
To the industry, of course, we get to promote ourselves, but the industry is such a small industry and we've got expertise, so it's kind of like, why not? We need to network, we need to understand the situation at the moment, and this provides a perfect platform to do that.
It's very informative, beat my expectations, didn't expect to this sort of audience yet, so it was very good.
It's very interesting, very informative, and I would definitely like to attend more of these.
A very nice presentation and a very nice insight in what's happening in the current industry.
It's interesting to hear the questions that get asked and how they get answered, to understand what the fears and the views are in the market out there.
It was very well presented. The speakers were very knowledgeable and all in all a very good evening.
Yes, it was quite enlightening, particularly the Eskom buyback situation, which is current. It gave us some perspective on the longer term views of Eskom on power supply, and for the industry, ferrochrome industry to adapt itself to be in line with the supply that Eskom can provide. So yeah, it was very informative, excellent presentations, and we enjoyed it a lot.
Well, yes, absolutely. There's always a need for information from the industry. Sometimes we lack in that, concentrate just on our field. So it's definitely good socializing with the people in the industry. Yeah.
I think it's a very good networking opportunity, and I think some of the opinions are different to what we always hear. So it's a good opportunity.
The speakers tonight were excellent. The other 2 speakers, excellent caliber, very interesting. And why Snowden is part of this is just in terms of ferrochrome, just broadening our network and just the opportunities that present themselves in this industry at this point in time.